Okay, in this video we will discuss how to find the sums of finite arithmetic sequences. Again, you did those in 9.1 from a very, very generalized basis, where you took each term and added them up. What's going to be nice about doing this for an arithmetic sequence is there's a nice tidy formula for that. So the sum, this right here means the sum of n terms of an arithmetic sequence. You can simply do using a formula. So n, of course, is the number of terms. In this instance, a sub 1 will be the first term still. And a sub n will be the, quote, last term, or the nth term. Okay, so there, that's kind of in general how it works, but basically we're going to take some small number of pieces and add them up. So rather than having to actually find each individual piece, we're going to jam them into this formula, and we'll take it from there. So let's look at this one. We're going to find the sum. Go back to sigma notation from 9.1. We're going to find the sum from the first term to the 100th term. So that means, by the way, there are 100 total terms. So n equals 100. And we are going to find the first term by plugging in 1 for n. So that will be 2. And a sub n is the 100th term. So that will be the a sub n in the formula, which is the 100th term. I probably should have. I'll fix that. A sub n in the formula is the 100th term. So that'll just simply be 200. And now you take this, the sum of the first 100 term, the 100th partial sum is 100 over 2 times 2 plus 200. Line it up just like that formula on the previous slide. So this will be 50 times 202. And that will equal 10,100. So that will be the sum from 1 to 100 of the sequence 2n. And so over here, we'll write that as s sub 100, the 100th partial sum of that sequence. 10,100. Okay? So that's, generally speaking, that is how this formula will work. It's just a matter of capturing the specifics of each problem as you go about them. And so this one, here's an arithmetic sequence. We don't yet know. We want to find the nth partial sum. We don't yet know the formula that generates the sequence, so we can look at it. Common difference here is 4. So a sub 1, there's no ellipsis here, so that's indicating that this is the first term in this sequence. So we can calculate that c value, -6, minus that common difference. C is equal to -10. So our formula is 4n minus 10. And so what we want to do is we're essentially finding the sum from 1 to 50 of 4n minus 10. So we've got, what, 50 terms. A sub 1, our first term, is -6. A sub 50, our 50th term, is 46, nope, 190. 200, of course, minus 10. So now we're going to find the sum of the first 50 terms by doing n over 2 times the first term plus the last term. So put this into our calculator, do it by hand, whatever. We get 4,600. That's where I was going with that 46 over here. And let's look at one more before we end this lesson about arithmetic sequences. Let's find the sum of the numbers 1 through 500. Let's not overthink this one. We're going from 1 to 500 of the sequence n. And that's it. The sequence is n because it's 1, 2, 3, 4, 5, up to 500. So, pretty basic. Sum of 500 terms. Adding 500 terms. First term plus last term. So this is 250 times 501, 125,250 if you add the numbers 1 through 500. And just as a little review, summary of the notation from everything going on in this unit so far, S sub n means the sum of n terms. Notation is a super important part of what's going on here. N usually stands for the number of terms in this context, but sometimes it, of course, means the term number. A sub 1 is, of course, the first term in your sequence, and A sub n is the nth term, or the last term, depending upon the context. So you need to make sure you're reading the context correctly. It could be the nth term in the equation, it could be the last term in a sum, or the also known as the equation that generates the sequence. So this is two different things, two different ways to call the same thing. And that is all about sums of arithmetic sequences.